Hi everyone, welcome to a new video. I'm trying out a whiteboard series. This is my first time attempting something like this, so I ended up, talking a lot, for 30 minutes. So I thought I'll just, cram in all the important points that I wanted to share, and then you can watch the video, the entire 30-minute video if you're interested. So the main points I wanted to discuss and share were um, the concept that it's more important to be thinking about modeling rather than prediction. And this is a point that I understood really from Vincent van der when I watched this video, Winning with Simple Linear Models, right? Because when you think about prediction, you're just thinking about the output. When you think about modeling, you're thinking about all the functional forms associated, how your model is getting to that conclusion, which is very important. Second thing, I was talking about 4 parts about, let's say, machine learning that I think makes more intuitive sense. The first point is the cost function. Now, an important question is, why do most people just end up going with mean square error? There are so many other error types, but we just end up using mean square error most of the time. Even though mean square is not probably the most ideal, let's say, loss function for the given problem. The second thing I wanted to say was optimization algorithms. Now, we all know SGD, AdaGrad, let's say Adam Optimizer. But again, we are missing the point. We don't necessarily have to stick to these optimization algorithms. If you have a very small data set and you have only like a few parameters to search for, okay, it's brute force the entire loss landscape. You will get a guaranteed local global minimum, right? And this handles well if you have noisy data and small data sets. Now, thirdly, I want to discuss about the model class. Why do we just end up using, let's say, a single model for a single problem? So you have linear regression for this or decision tree for this. Why don't we use linear regression to model a certain the output of a certain input variables, and let's say a decision tree for other input variables? So you have like a boosted multi-level model, right? Then fourthly, I want to discuss about how most of the times we as machine learning practitioners have to deal with noisy data, and it's not feasible to get more data because it's going to be costly, and the solution might be to use sample weights. And this is very well explained by Vincent van der video on sample weights, where he explains there's a good trade-off between throwing away, let's say, irrelevant data and just using irrelevant data. There's a fine balance which allows your model to learn some useful information from this, let's say, irrelevant data or poor quality data. So those are the few points that I want to discuss, and hope you enjoy the